So our next speaker is Professor Max Tegmark, which is a professor at MIT, and his research encompasses cosmology, physics, and machine learning. He serves as president of the Future of Life Institute, advocating for the beneficial use of technology and addressing existential risks associated with AI. So Professor Tegmark has authored over 200 publications and many popular science books. So let's welcome Max.
Thank you. It's a great pleasure and honor to be back here. Yeah, so 8 years ago, I decided to switch my MIT research group from physics to machine learning, and this is just so much fun. I'm an optimist, and I'm going to argue today that we can have a really, really inspiring future with guaranteed, safe, generative AI if we avoid building AGI anytime soon, which I'm going to argue is unnecessary, undesirable, and preventable. Now, this is kind of natural sequel to what Joshua just told you, because he made a very nice case that non-agents are safe and can give us great benefits. Non-agents being things that have no goals. I'm going to add further optimism to this and argue that actually in the Venn diagram there are even more things that we can also make safe, which are what I call tools that might have goals, but they're controllable. So as long as we stay away from the red stuff. So I'd like to start with a show of hands here. Who wants us to make AI tools that can help us cure diseases and solve problems? That's a lot of hands. All right, now, who wants AI that just makes us all economically obsolete and replaces us? See, one hand over there, two hands. So, pretty lopsided vote there. Now, there are gloomers who claim that we can't have what almost all of you voted for there without also the second part, being disempowered, et cetera, et cetera. I think I'm going to argue that that is really a myth. We can actually have the cake and eat it. And I'll spend the rest of my talk explaining why that is. The part that almost nobody voted for here, AI that just makes us economically obsolete and replaces us on the job market and maybe later even altogether, is basically AGI, right? As Joshua mentioned, smarter than human AI that can outperform us at virtually all tasks. And as Joshua mentioned, that includes by definition the task of AI development. So if you have a bunch of robots that are just much smarter than us and can build robot factories and make new robots, etc., and soon you have much more robots than you have people, it's pretty natural that we might lose control over them. We haven't made just a new technology now like the internet, but a new species. So why am I so optimistic? Suppose I told you that, or suppose someone told you that you have to have completely unregulated biotech with eugenics and human cloning, etc. Otherwise, and maybe gain-of-function research that you could lose control over. Otherwise, you can't have any medicines whatsoever. You would call BS on that, obviously, because you know there's the third way. If you have safety standards, you create an incentive for companies and academics to work really hard to figure out how to meet those standards and produce all the wonderful, safe medications that we have today. And in the same way, if someone tells you that you have to have completely uncontrollable AGI, otherwise we'll never be able to have AI that cures cancer, folds proteins, or makes awesome self-driving cars or whatever, you should call BS on that for the same reason. Because obviously, if we have safety standards, then we're creating great incentives for industry and academics to innovate and meet those standards and give us all these great tools. But, you might say, AGI is really just science fiction and decades away, so why don't you just shut up and get off the stage and come back in 30 years, Max? Well, this used to be a very popular position to hold because, frankly, AI used to suck. And then this next one is even, this is particularly embarrassing to me to show this video because the next one is actually the MIT robot coming up here. But welcome to 2024. AI doesn't really suck anymore. It's remarkable how much progress we've had. Now we have robots not only that can dance, but they can do all sorts of other things, even fold your laundry. So, and in terms of generative AI, the theme of this session, it went in 1 year from producing this to producing this with exactly the same prompt. And as recently as 5 years ago, most of my AI research colleagues predicted that something that could master language and knowledge at the level of Claude or GPT 3.5 or GPT 4.0 or 1 was decades away, maybe 2050, maybe 2040. That was obviously wrong because we have it now. And when Joshua argued last year that AI can now pass the Turing test, I agree with that. And the forward momentum looking ahead is just massive. If you add up the entire expenditure on the Manhattan Project from 1942 to 1946 and adjust it for inflation, it's less than a quarter of what was spent just last year on AI. And this massive forward momentum, of course, has really shifted the timelines in many people's minds. You can see it on prediction markets, where the time remaining to AGI has dropped from decades away to 2 or 3 years away. And people like Dario Amodei from Anthropic put a number on it. He thinks it's 2 years. Sam Altman has this to say.
This is the first time ever where I felt like we actually know what to do. Like, I think from here to building an AGI will still take a huge amount of work. There are some known unknowns, but I think we basically know what to go do.
I disagree with Sam on many important things, but I agree with him here. I think there's no strong argument why we should be super sure that this is far away. And I think we have to stop taking for granted that AGI is a long-term issue, or someone might make fun of us for being dinosaurs, stuck in 2021. But, you might say, AGI is necessary because we've been at NeurIPS all week hearing people talk about all these exciting things, and we're going to lose out on all that stuff if we can't make AGI, right? No. This is totally a myth that we need AGI to get AI's upside. I'm going to argue that it's actually unnecessary that we can get basically all of the exciting benefits I've heard about all week here at NeurIPS without AGI in the near term. For example, we can save about 1 million lives on the world's roads by eliminating traffic accidents with autonomous vehicles using tool AI without AGI. Tool AI can save even more lives in hospitals without AGI. Tool AI can diagnose prostate cancer, lung cancer, eye diseases, and countless other things, democratizing access to fantastic healthcare without AGI. Tool AI can help us fold proteins and revolutionize drug development and drug discovery, and even get you the Nobel Prize without AGI. Tool AI can help us with pandemics. Tool AI can help us save energy. Tool AI can help make education more accessible and personalized. Tool AI can transform basically every sector of the economy to produce goods and services more efficiently without AGI. Tool AI can, as Joshua mentioned, also help us attain the Sustainable Development Goals faster. This is from a Nature paper I was involved with recently. And so in summary, it's really a myth that we need to rush to AGI as fast as possible, otherwise somehow all the excitement here at NeurIPS is going to go away. That's just not true. But, you might say, AGI is controllable anyway, so why don't you just go sit down and relax? There's nothing to worry about here. I want to just add a little bit to Joshua's argument that no, it's not controllable.
Once these artificial intelligences get smarter than we are, they will take control. They'll make us irrelevant. And that's quite worrying, and nobody knows how to prevent that for sure.
So you notice that very many leading AI researchers are saying this, and it's quite striking that the main people who are not, it's very hard to find prominent AI researchers saying it who don't have some sort of financial conflict of interest with companies. And it's an old idea. Alan Turing said this, what you heard Jeff Hinton say there, and what you heard Joshua say, Alan Turing said it in 1951 already. Expect the machines to take control. It's important to remember that, like, when Turing says things like this, he's not thinking of, if you just think of AGI as a new technology like the steam engine or the printing press or the internet, it feels really like hyperbole, right? But he's clearly thinking about it as a new species instead, as I mentioned in the beginning. If you have systems that can do everything better than us, including building copies of themselves in robot factories and stuff, that is the definition of a species. And then it's very natural that the smarter species controls. Why do we humans control tigers? Because we're smarter, right? And it has nothing to do with some weird speculation about the AI turning evil or turning conscious. The concern is simply turning very competent and having goals that aren't aligned with ours, as Joshua mentioned. And if you're chased by a heat-seeking missile, you wouldn't feel calm and relaxed and be like, oh, I'm not worried because this machine can't have goals in some deep philosophical sense. You don't care about that deep philosophy. You just care that it's acting as if that has a goal. That's where the threat comes from, right? And if you say to yourself, oh, AGI will become kind and so on just because it's smart, so let's just build some smart machine and have it figure out everything for us. No, if Hitler had been smarter, things wouldn't have been better. Things would have been worse. So it's for reasons like these that so many people, from Alan Turing through to Sam Altman, have been warning that this could really be game over for humanity. It could be lights out for all of us. It could cause human extinction or just some kind of Orwellian permanent disempowerment of humanity. And last year, who's who of AI thinkers came out and said this could even be something that could maybe cause human extinction. And I have to give a compliment to companies for spending at least some of their money on trying to solve the control problem. But honestly, they're nowhere close. Right? The biggest success so far of these corporate efforts has been training large language models to not say harmful things, as opposed to not wanting harmful things. That's like successfully training a serial killer to not say anything that reveals their murderous desires. Problem solved, right? And it's even worse than that because I think it's getting increasingly obvious now that the first AGI, if we get one soon, is not going to be a pure large language model, which is the context in which most of this safety work is done. It's going to be some kind of hybrid scaffolded system, maybe an ensemble of different LLMs interacting with each other and interacting with a bunch of tools and other AI techniques. And if something like that is recursively self-improving, we really have no idea still how to control them. But, you might say, who cares if we can control it? It's desirable to just have this new successor species or whatever. We had only 2 or 3 hands saying you wanted something that replaced us, and I suspect some significant fraction of those 2 or 3 people where you were joking because you like to be contrarian. But there are, let's face it, a number of very serious and respectable thinkers who actually want this, who want uncontrollable AI. For example, I really like Professor Richard Sutton, amazing pioneering work in machine learning. And you can see him on YouTube talking about how he feels that this AGI that we lose control over is just the natural next step in evolution, and we should welcome it. You see Beth Jesus, who founded the EAC movement that many of you have come across on Twitter, tweeting out here how he thinks it's just fine if all biological life gets replaced by machines. And his great fan, Mark Andreessen, has this tweet here where he says that AI is going to be gloriously, inherently uncontrollable. So if you lose control, he actually thinks it's good. And in your show of hands, it was clear that almost none of you agree with this perspective. But these people have a right to their own opinions. But so do the rest of us. And I think of this school of thought as digital eugenics, basically craving to replace ourselves as a sort of digital master race. And although they're entitled to their opinions, that doesn't mean we have to share it. I personally don't share it. I would really like my 2-year-old son, Leo, to get to have a meaningful and long future, even if someone else is drooling over the idea of a digital master race. I'm a sucker for democracy. I think everybody should have a say in this, and we shouldn't just let some fringe minority decide all this stuff behind some locked doors or in a boardroom somewhere. But, you might say, AGI is inevitable anyway, so just shut up, Max, sit down, and don't waste our time fighting against the inevitable. Actually, it's not inevitable. You might think it's inevitable that you're going to get every technology that can give money and power, but the data shows this is not true. We have banned many, many powerful technologies that you could get very rich off of. If I could make a lot of clones of you, Joshua, for example, in human cloning, I could make a ton of money. But we banned human cloning. Human germline editing, we also decided just to not do, because biologists felt this was a little bit too risky. We might lose control over the future of our species. Bioweapons can give you great power. We banned them. So if there's enough stigma around something, then we will, as a species, often just decide, hey, we're not going to go there. And if you run into someone here at NeurIPS who's like very red-pilled on AGI and is like, we must have AGI immediately, whatever, give them a little bit of a hard time and maybe remind them that if they have power or agency that they appreciate, they stand to lose it all if we rushed into this too fast. And also, if someone still tells you it's inevitable that we're going to get AGI, just imagine that they would go into the FDA and say, hey, I have a biotech company and it's inevitable that 3 years from now I'm going to release this new super drug in supermarkets, and I hope you guys at the FDA are going to figure out how to make it safe in the meantime. Maybe you can fund some government, some safety research. They would get laughed out of the office. They'd be like, hey, dude, where's your clinical trial? Oh, you don't have one? Come back when you do. Next, please. So if we have some safety standards as a society, which we actually have for every other industry, then automatically releasing unsafe things is not inevitable. It becomes the other way around. But China. I'll save the best one for last, because this seems to be the most effective argument at least south of the border here for ending all conversations about not racing to AGI. Maybe we'll lose control over it, maybe it has all these risks, but we have to do it anyway before China does. This argument is, of course, completely misframed if you think about it. I call this push to have a geopolitical battle to build AGI at all costs before China does. This sort of battle, the race to AGI, I call it the hopium war, because it's fueled by hopium. This delusional hope that we already know how to control this stuff. Why? Because, let's face it, we are closer to figuring out how to build AGI than we are to figuring out how to control it. So that means that the AGI race is not a traditional arms race. It's a suicide race. Just like raise your hand if you saw the movie War Games once upon a time.
Strange game. The only winning move is not to play.
Strange game. The only winning move is not to play. If China builds superintelligence and then loses control over it, then after that, the Chinese Communist Party is not going to be in control of China. So they have no incentive to do it if they believe that they're not going to be able to control it, and vice versa here in the West, right? Yet it's very often misconstrued and described as a very traditional arms race, where the U.S. government had a report out recently saying we should race to build AGI, and they just took as an axiom that of course we can control it. I was in a debate at Rand Corporation last week, or a week before that, against the authors of this report, and I asked them, well, why didn't you even mention that there is such a thing as a control problem that some scientists have actually talked about? Why wasn't there even like one sentence about it? And they thought, we didn't have space for it in the report. Do you know how long the report was? 760 pages. So, with these 6 buts I mentioned, I tried to make the point that none of the objections to what Joshua and I were pushing here are particularly solid. So what do we do instead then? Let me spend my final time here outlining my optimistic vision for how we can have a really great future with much, much better and more awesome AI that we stay in control of. So as I said in the beginning, it's a false choice to think we have to just have completely unregulated AI with no safety standards or nothing and go back to being Amish or something. If we treat AI like any other industry and have safety standards in place, there's going to be huge incentives for companies now to meet these safety standards and innovate, and so same for us academics. We can have a really great future. There's a nice long document called The Narrow Path put out by Control AI that suggests a policy vision for this that I think is really good. I'll give a little more of a colorful summary of how I think about this. So there are 2 things that have to happen. Some on the policy side, some on the nerd side. On the policy side, as Joshua said, governance is very important. And the way I see this playing out is if once it becomes more clear for more nerd research to the policymakers that the control problem exists and we're nowhere near to solve it, then both the US and China will just unilaterally enforce national safety standards. Again, AI is the only industry right now that has no safety standards at all. In the US, even if you want to open a sandwich shop, there are safety standards. You need to have a health inspector come in first and see that you don't have too many rats in the kitchen. So US will impose some safety standards, not to appease China or anything, but just to protect Americans, and China will do it independently. When the FDA was created in China and in America, they didn't have a treaty inspecting each other's FDAs. They both did it selfishly. So no coordination is needed there. But then once that's happened, there's a really interesting geopolitical dynamic that plays out, because now they'll be like, wait a minute, how can we make, okay, so we know our companies aren't going to make AGI anytime soon because they don't know how to control it yet, but how do you make sure North Korea doesn't do it? So now the US and China have an incentive to jointly push the whole rest of the world to join them in having comparable safety standards. And I actually think that conveniently the US and China together have enough geopolitical clout that they can pressure North Korea and every other country into joining them in this. And at that point, we enter an unprecedented phase of global prosperity powered by by safe non-agentic AI and safe tool AI that I'll talk more about, a real golden age where the NeurIPSs are just going to be ever more fun to go to every year. All the fun, none of the angst. And then on the technical side, what needs to happen there? Once you have these safety standards, right, the incentives in companies and universities change a lot. If you go to an AI company today, a lot of engineers feel that the people on the safety team are just these annoying whiners, you know, who are slowing stuff down and worrying all the time. If you go to a biotech company, that's not at all the attitude that people there have about their clinical trials people. They love their clinical trials people because they see them as the ones who are going to get them to market faster by succeeding to make things safe. So as soon as you have safety standards, the dynamics change. Companies, leading AI companies, spend much more money on AI safety, and the people in the safety team feel really appreciated. And there will be a massive amount of innovation. What kind of innovation am I most excited about? So Joshua and I and a bunch of colleagues here were on this paper about guaranteed safe AI. And you heard a bunch of it, those of you who were here earlier this morning from Joshua, where you actually have quantitative guarantees or other reasons to believe that your systems are going to be beneficial. Guaranteed safety can mean that you have a quantitative guarantee, like we have today. If you want to build a nuclear reactor outside Vancouver, they will ask you to make some calculations and show that the risk of a meltdown is less than maybe 1 in a million per year. It's not zero, but it's low enough. It's the same with drugs. You don't have to prove that nobody ever is going to have a side effect from the drug, but you want to have something quantitative. Now, the most extreme kind of quantitative is if the probability of the bad thing happening is 0. That's what Steve Omohundro and I were talking about here in our paper about guaranteed safe AI. Sorry, provably safe AI. And the idea there is that, just as with physical systems, we put in place guardrails, right, to minimize harm. But these are not impenetrable. If you, so the ultimate sort of guarantee is if you have a mathematical proof that your code or your system isn't going to do certain things. Because then even if the AI is way smarter than us, it still can't do the provably impossible. And I want to add a bunch of optimism here. So far, the whole field of proving stuff about computational systems, known as formal verification, it's been around for a long time, and frankly, I think it's been kind of disappointing. It has very little uptake, mainly because it's so hard to do. It's so expensive to do and very human labor intensive. But this is all going to change because of AI. I think it's quite obvious that just as AI has swept in like a tsunami and disrupted our ability to generate art, generate text, and now generate software. Raise your hand if you ever used the Copilot or something to accelerate your work, right? We're sort of in the beginning of a huge, huge sea change there. AI will also obviously revolutionize our ability to make proofs for stuff. We're beginning to see it already in proving stuff about math, and it's clearly going to happen for proving stuff about code. I'll come back to that in a bit of more detail, how we can further accelerate the adoption of this. But I wanted to share another optimistic thought with you first. I've worked a lot with my MIT group on mechanistic interpretability and trying to figure out how large language models actually do stuff, and many others in the audience have too. There's a workshop next door on it today on interpretability, and it's hard. It's very hard to prove a lot of things about today's most popular architectures. But maybe you don't have to for a lot of really cool tools you want. We have to, I think, let go of this idea that just because we use AI systems, neural networks, to learn stuff, we also have to have the deployed tools, you have neural networks in them. I think that's a mistake. Like, suppose, for example, that Joshua Bengio comes up he thinks about it hard and comes up with a really cool algorithm, better algorithm for navigating a rocket, for the control of a rocket that's going to go to Mars, And it's really important for you that this rocket doesn't crash or something because you're going to send your family on it, One approach, which is kind of the current default approach people assume is, okay, you put Joshua Bengio in there to steer the rocket. And then you're like, oh, let's formally verify Joshua's brain. And let's figure out how his brain works and try to get provable guaranteed. Does that seem really easy and feasible? No, right? What would we do instead? We'd be like, hey, Joshua, I hear you came up with this cool new algorithm. Can you just code it up for us in C++ or Python or something? He would do it. And then we can study the code. In fact, we can try to formally verify the code and get a rigorous mathematical proof that it works. That's clearly much more feasible, right? So back up a little bit here. What I'm saying is, if you compare neural networks with more traditional forms of software, it's obvious that neural networks are much better for a lot of stuff. But what exactly is it that they're much better at? Is it that they're much better at runtime to just execute the algorithms? No, actually. A neural network is a very efficient, massively parallel computational architecture, right? Turing complete. But hey, so is massively parallel C++ and all sorts of other languages, right? Neural networks are not worse, particularly, but also not particularly better than traditional software if you're just executing known algorithms. So where is it that neural networks are so much better? It's for the learning. That's where they shine. And the real superpower of neural networks doesn't come from inscrutability. We don't understand how they work. It comes from the differentiability. That you can always compute. Any set of parameters is a valid program, so you can compute gradients and use them to automatically learn the algorithms. They can learn all these algorithms that we humans hadn't even thought of. Good luck taking a gradient of a C++ program to see how you should improve it, right? So in other words, what I'm saying is a paradigm that I'm actually very excited about is as we use powerful machine learning systems that we don't trust to invent algorithms, discover knowledge we need, and then code it up in more traditional languages. And then we use either we ask the same AI system or a different AI system to also find a proof that this AI tool meets the specs that we humans have written down. And you might say, oh, this is hopeless, obviously. I don't understand how this powerful AI works. I can't read the tool. The code is too long and messy. Can't read the proof. It would take you a lifetime. But here's the really great news. Just like it's much harder to find a needle in a haystack than it is to verify that it's a needle after you found it, it's much harder to find an algorithm and find a proof that it meets your spec than to verify it once it's been found, right? In fact, you can write a 300-line Python code that will check any proof for correctness. So it's perfectly feasible for you, the human, to understand the spec you wrote and understand the proof checker. And now you can suddenly start trusting something, a super powerful tool, which was written by a completely untrusted system. It's a bit like if some mathematician you never heard of who was convicted twice for fraud comes up with a proof of the Riemann hypothesis. You don't have to trust her or him as long as you can check the proof. And that can be automated. Something that Joshua has emphasized a lot, which I think is very important, is that we want technical solutions that scale in the right way so that the technical solutions become more effective rather than less effective as AI gets more powerful. And what I'm pitching here has exactly those properties. Because the more powerful AI becomes, first of all, the better it'll become at discovering new algorithms and also writing them up in code. And the better it's going to be also at coming up with proofs. So I think it's super interesting to work on this stuff now, scale it up, and then watch how, as AI gets better, asymptotically, the gap between how awesome and how powerful these AI-created provably safe tools are and what unsafe things are, I think will shrink as things scale. If you can't figure out how to, and even if the AI cannot, in a traditional way itself, write down its algorithm it's figured out, you can also have another approach where you have an AI neuroscientist, so to speak, that looks inside, has access to all the weights, and tries to figure out the algorithm and code it up. A little toy example to just show you that it's not impossible is this paper we recently did where we trained the neural network to just learn 63 different numerical algorithms from data. And then we wrote a fully automated machine learning system that looked inside at the weights, figured out what algorithm was learned, and distilled it into Python code. So we could throw away the neural network. As a simple example, we did an algorithm you probably learned in first grade or kindergarten or something for adding up numbers, where you loop over the digits and do a carry operation. And so we would train a neural network to get perfect accuracy, and then we would. What the automated system found was that in a certain latent space, after a while, it looked more like a finite state machine. And in this particular case, it could be interpreted as 2 bits. And then by looking at the finite state machine tables, etc., one could figure out what it was actually doing, and it produced this Python code completely automatically, and it's rediscovered the so-called ripple add algorithm here, which is actually the one we learned in first grade, where it turns out that the B variable there is the carry bit, et cetera, et cetera. And we also saw many examples where we noticed that it's neural networks, even though this latent space is continuous, it's representing integers as these lattices. And we came up with an algorithm for taking arbitrary incomplete integer lattice, which was messed up by an affine transformation, and figuring out what the integers were. There's a lot of exciting progress in this field. Both the previous speaker and the next speaker are very excited about it. And we're working together on it. And in summary, formal verification, I think, can really be scaled up in a big way. And I want to end in my final 4 minutes here just talking about some imminent opportunities for accelerating this process of formal verification. So I think there's a great opportunity to make this progress faster with open source community building. The vision here is that, so right now, the adoption is very low. So there isn't very much formally verified code, so there aren't any good benchmarks and training sets to train machine learning on. If we can get larger benchmarks, then of course, folks like you will train on them to make better automated provers, and that in turn will produce tools, verification co-pilots, right, that make it much more fun and quick and cheap for people to do formal verification of code. And then we get larger code bases, larger benchmarks, and we can go around this virtuous circle. Right now, things are really very fragmented in this field. A lot of people who have worked on formal verification for years don't know much about machine learning and don't know a lot of machine learning people. There's a horrible lack of large benchmarks. And the code that people write is very fragmented too. Some of the biggest hits and successes in formal verification are each done in a different language. Amazon Web Services just completed this massive project where they formally verified their whole login and credentialing system, so they will never have to do another security patch ever. They did it in a language called Daphne. The greatest math library that's formally verified is in Lean. The first ever formally verified C compiler, CompCert, is done in Coq. When they did this, they found over 100 bugs in this previous C compiler. So the correct C code gave incorrect machine code, like, the first formally verified microkernel was written in Isabelle HOL, and the simplest proof checker is in a fifth language called MetaMath. And there is no automatic translation between these. So to realize how annoying this is, it's like, suppose a French mathematician proves some cool theorem, and an American mathematician proves another cool theorem, but they can't ever be combined by anybody because nobody knows how to translate between French and English. So let's look a little bit more at the sad state of benchmarks here. For mathematical theorem proving, we have many benchmarks now with of order 10 to the 5 examples of theorems that you can have contests, people try to prove. And as a result, the ability to automatically prove these things has gone up from success rates like 2% of those benchmarks to like over 70%. For formal verification, the biggest benchmarks at the beginning of this year was 66 programs on one of them, 153 on another. There's so much room for improvement here. We did one recently where we at least took it up to 750 examples. In this Daphne Bench paper, spearheaded by Wendy Sun and Chloe Lowbridge, we basically took formally verified code from GitHub, where there's an algorithm and it's supposed to meet the spec there in blue at the top. And then we threw out the so-called hints that humans have to put in by hand to make the proof work, and then we asked just standard off-the-shelf LLMs to see if they could put back enough hints that the proof would work, so it could all be done without human input. And even with this minimal effort, we get like 2/3 of them succeeding. I hope you can beat this performance with better algorithms and help make bigger benchmarks. And then on the community side, we just launched last week a website called verylib.org. It's an open source project for formally verified code where you can go upload your stuff. And we have proof checkers in the background. So if you come as a user, everything you find here is guaranteed bug-free. You don't have to trust those who wrote it because it's been automatically checked. And we hope this site will help basically get this virtuous circle going faster. It's like a guaranteed bug-free version of Hugging Face. To summarize, I'm an optimist. I think we can have a fantastically inspiring future if we just impose some national safety standards, which countries don't have to negotiate about or trust each other first, and incentivizing all sorts of wonderful AI research so that we can basically have our cake and eat it. We can continue going from NeurIPS to NeurIPS with new cures for diseases and all the other wonderful stuff we want without having to constantly worry that someone is going to ruin it all by creating something that we lose control over. In other words, just to summarize, we just have to remember this lesson from ancient Greece and not get hubris. If we have a very long future for humanity if we don't do something dumb, so let's not rush it and jinx things. Artificial intelligence has given humanity incredible intellectual wings, which we can use to accomplish things beyond our wildest dreams. Right? If we heed this warning from the myth of Icarus and don't get hubris, stop obsessing about flying to the sun or building AGI as fast as possible. Thank you. Sure. Great.
So we still have quite some time for several questions. Please raise your hands if you are interested in, okay.
This one.
So,
do you have a microphone we can pass around?
Okay, I should maybe ask.
These ones work if we can turn them on.
Oh my God.
We have microphones here. Should we use them?
Yes.
Yeah,
Sorry, from...
Mine works. I just wanted to give him one.
Yeah. So we have.
Oh, fantastic. All good.
Oh, I didn't see that.
I didn't either. So
okay.
Where is it?
Over there. It's around there. It's the same.
See where the gentleman is waving his arms? That's where you should go to ask questions.
Yeah, you can.
All right, take it away.
Yeah, since I have the mic. Thanks a lot. This was a very interesting talk. I'm Pushkar from DeepMind, and I really love this idea of having guarantees. And personally, I'm a big fan of air crash investigations. And it's very interesting, like what you can learn from the airline industry on how every part is verified to not fail in a certain number of takeoff cycles or landing cycles. And every part comes with like an operational guarantee that if operated within these paradigms, the part will not malfunction. And I just wanted, so I have a comment and just a question. The comment is that, and maybe you have already thought about it, the comment is that there's definitely guarantees and we should be able to provide those guarantees for different operation models or different modes of operation of a model. The other aspect of this is maybe having a proper AI accountability framework for when we cannot have these guarantees or when the guarantees are not very clear. So that's my comment, if you want to respond to that first. Or
Yeah, maybe just say everything together so we can fit in one or two other questioners also.
Yeah, and the second point is, I don't know if you've already thought about it, but an interesting aspect of this is what do these guarantees and accountability framework look for foundational model, like system level implementation versus foundation model level implementation and so on.
Great. I think I'll answer the two together. I think aircraft industry is very inspiring. You can see having safety standards has taken the fraction of planes that crash from being like 1 in 4 or so right after the Wright brothers to making it ridiculously safe. The probability of you dying during 1 hour in an airplane is not only less now than 1 hour in a car, but even then less than 1 hour in your home, it turns out. It's amazing. And so these incentives are incredibly important. And for the second question, I think it's the wrong framing to say, oh, to ask some random professor on a stage or some governance person to figure out how to make things safe. As soon as you have safety standards, you provide wonderful incentives for the companies to innovate and answer all those questions. And I have a lot of friends at DeepMind, and I don't want you to take this personally, but I do think it's disappointing that DeepMind has used their lobbyists to try to push against regulation, even though we really need some safety standards very quickly. So as soon as we can just rally around this idea that we should have some safety standards, which can be a very low bar initially, then I'll feel way more optimistic. Next, and let's make sure this is just a question so we can have time for
the quick question. So you say you're optimistic, but then you also say that 1 to 10 years we're going to have AGI. We might have AGI. Companies are racing. They're saying, right, vocally that they're racing for it. And governments move slow, right? Governments are not very fast at putting in regulation.
Yeah.
How are you optimistic given all those facts?
You're hitting exactly the crux here of the question. We will get it's quite likely that we will get AGI soon, I think, if there are no safety standards. But that's exactly what the problem is. It's like if we had no safety standards for biotech, it's very likely we also will have some very unsafe medicines within the next 10 years. But we don't worry about that because we have an FDA, et cetera. And so as soon as we can have some safety standards in place, then it's pretty clear we're not going to get AGI next year because no one has figured out yet how to control it. If someone can figure out how to make it really safe and convince everybody, all the experts, that they meet the safety standards in 20 years, yeah, maybe we'll have it then. But in the meantime, nobody is going to be allowed to release something they can't control. But in the meantime, as both Joshua and I have argued here, we're going to get wonderful other AI innovations, fantastic non-agentic AI, fantastic tool AI, maybe a cure for cancer, remarkable autonomous vehicles, and amazing free education, customers, all this other great stuff, right, will happen. So it all starts with just putting in place safety standards so that the nerds of us here can just get back to doing research on good things and not have to worry about there being some kind of rush. The whole stress we feel, oh my God, are we going to figure out how to make it safe before someone releases this? It's just complete nonsense. There's no other industry where we lack safety standards and have to stress like this.
Hello. On your right.
This is the last question, yeah?
Okay, so...
you're the boss. They're saying that there's someone here.
Okay. So this is about what you were talking about earlier, where you were saying that you want a joint initiative from like China and the US to ban unsafe AI. So I feel like you didn't really touch on how we would go about actually enforcing such a policy, and what would be like the timeline of that? Because I feel like most people. Okay, go ahead. Go ahead.
Great question. So framing is crucial here. I think it's very unrealistic that the US and China this year are going to start hugging each other and trusting each other and so on. So my very optimistic point is you can have some really great things happen without even before any of that, right? As soon as people in the US NatSec community and the US government start to realize that we're closer to building AGI than to figuring out how to control it, they will put safety standards in place in the US. They would do it even if China didn't exist. Same in China. They will put safety standards in place there, just like they made a Chinese FDA, right? Doesn't require international coordination. And it's enforced individually by the separate countries. If we have some kind of FDA for AI in Canada and another one in the US, they're locally enforced. That can happen as soon as the politicians start taking it seriously. And then after that, if you look, officials from the Chinese FDA and the US FDA, they like to talk to each other a lot about sharing best practices and harmonizing a little bit so it's easier for a company that gets licensed in one country to sell in the other. That kind of takes care of itself. But I think it has to start very quickly from the grassroots level, and then it can start with us. If we just, whenever we talk to policymakers, just remind them that there's more safety standards on sandwiches right now than on AGI. And if one of the companies had AGI tonight, they would be legally allowed to just release it tomorrow and see what happens. That's nuts. Thank you. And I can take more questions in the coffee break from anyone who didn't get to ask it now. Thank you.